man, it's time to add and subtract rational expressions, still with the 97 Bowls championship hat with the tags on it. All right, so how are we going to simplify here? Well, if I want to add, do recall we need like denominators. How do I get like denominators here? They're completely different from each other. You can't just say, oh, they both have an x, because x minus 2 is together. X minus 1 is together. It's a binomial. All right, so those two are considered to be completely different, nothing in common. All right, so now what I need to do is I need to figure out how am I going to get them to be the same. Well, I can multiply this one by x minus 1, and I got to do that in the denominator too, right? And over here, I can multiply by x minus 2 and x minus 2. That way, I'm going to have x minus 1 times x minus 2 as my common denominator. All right? It's the same kind of idea if you had like 1 over 7 plus 2 over 3. 7 and 3 have nothing in common. You multiply by each other. 3 over 3, 7 over 7, right? Whereas if it was like say a 6, well, you can just do the right fraction, multiply by 2 over 2. Had something in common. Not the case here. Okay, that's enough side math. Back to the math. Let's see here. We got 3 times x minus 1 plus 2 times x minus 2. And at this point, I'm going to throw it all over x minus 1 and x minus, almost did plus again, minus 2. All right, now, be careful here. Some people are like, ooh, we're going to cancel away and it's 5. No, wrong. I need to distribute in my numerator first. So I got 3x minus 3 plus 2x minus 4, and then I can combine some like terms. So I'm going to do that without writing my denominator again. I'm going to have 5x minus 7. Now I will throw that all back in my denominator, or throw my denominator back in. And 5x minus 7, I can't factor that, so I can't get any kind of cancellations to happen here because there's no like factors. That is my final answer there, and that was super awesome. Let's try one more just like that. Or is it just like that? I don't know. Looks like I need to factor my denominator here first. So let's do that. My numerator will stay the same. I'll have, actually, you know what? I'll just write it below it. 2, and then I'll have x minus 2. My other denominators I can factor out. It'll be 4, and then I'll be left with x minus 2. Okay, so for this one, we have x minus 2 and x minus 2 the same, right? Don't need to worry about that. But it looks like the left one needs to be multiplied by 2 to match the right one. So what I'm going to do is I'm going to multiply by 2 over 2 here to get my like denominators. So now I'm going to have 2 parentheses x plus 5, and it's going to be minus, and then it's 3x plus 8. The parenthesis there is very important. We'll talk about why in a sec. Now my denominator I know is 4 times x minus 2. All righty. We are ready to rock here. I need to distribute this negative, okay? That's why I threw the parentheses there. That negative needs to also apply to the 8. So I'm going to have 2x plus 10 minus 3x minus 8 all over 4 times x minus 2. Now let's combine some like terms and see if there's any kind of factoring that can occur to allow us to cancel, okay? Whoop. I'm going to run out of room. We'll go this way. Whoosh. So now I'm going to have negative x, and then it'll be plus 2 over still 4 times x minus 2. So nothing the same, but hold up. Could I factor out a negative 1 in my numerator? I would be left with x minus 2. Ayo! So I got 4, and then we got x minus 2. Now we can go ahead and cancel these, and I'm going to be left with negative 1/4 as my final answer. Just negative 1/4. That's crazy. That's crazy awesome is what that is. Super dope. See ya.